class. In practice class of
No, that's not. We'll leave it for the practice session. So let's finish normalization. It is important now to do it. Okay. When we come to the practice, we will talk about it, inshallah.
Okay.
We said that for the functional dependency, if you remember, we said that we do have, for instance, this A is an attribute, B is an attribute, or attribute. It represents attribute. We say that B has functional dependency on another attribute A if, for instance, whenever you do have a record, okay, whenever you do have two records, they have the same value for A, automatically they will have the same value for B. As we mentioned, when you do have, for instance, employee and the number, automatically you can get the email address. And we said that in terms of the functional dependency, you can deduct it or define it based on the semantic. So the designer of the relation, it is the guy or the person who is responsible for defining what are those probable functional dependency based on the meaning of the attribute or the semantic. Okay, it's not like automatically it is defined. So you do your relation schema and you will define what are those different types of functional dependency. And we said there are many notation for functional dependency. The one we are going to adopt is this one. Okay, when you define your relation schema, and what you do, the left-hand side in functional dependency, okay, the left-hand side will have a line without any arrow, and anything with a line with arrow will be considered as the one that is on the right-hand side. Okay, this is the left-hand side, and this is the right-hand side. That means you are going to put a line from employee without any arrow, بدون سهم, okay, and you go to employee email. Okay, I go, for instance, employee name, I do have employee F name. From employee name, I do have employee last name. That means if I know the employee number, I can tell you what is his email. If I know the employee number, I can tell you what is his first name. If I know, or by knowing the employee number on the left-hand side, okay, which is the left-hand side, I can tell you exactly what is the employee last name. So these are what are known as functional dependency, and this is the way we are going to do the notation. And here, for instance, we look at this example last time, and we said that whenever you do have, for instance, when you do have, these are the functional dependency, the probable or the possible functional dependency. When you do have the text, you can get the course. Okay, when you get, for instance, teacher, you can know the course. For example, for a Smith, I said that Smith, for this teacher is teaching course data structure, for instance. Okay, a text will be now the problem here. If you know, if you look, for instance, for the text, okay, for the text to teacher, okay, if you know the text, I cannot tell you exactly what is the teacher, which is text teacher. Why?
Because text can be repeated.
Because no, it's not like that. Can I have, for instance, if I tell you I do have a text Martin, can you tell me the teacher?
No.
Why?
No. Because you need the teacher attribute.
No.
You need the teacher attribute. You cannot
because,
depend on.
For instance, if you look at that Smith, this guy.
Yes,
teacher,
we have two teachers with different texts.
Yes, with different texts. I cannot tell exactly, for instance, what a course text, for instance, course text. I cannot tell you exactly what are they. So these are with regard to functional dependency. Let's have a look at this one, for instance. If you consider A, B, C, D, okay. If you can you see my screen, Shabab?
Yes, doctor.
Yes.
These are the attribute, okay, A, B, C, D, okay, and I'm looking now for the tuples, okay, where, for instance, I can have some functional dependency. If I tell you, for instance, B to C, whether this it can be considered as functional dependency or not without any violation. B2C, what is meant by B2C? Just look at the columns, B1, B2, B2, B3, A1, A1, A2, A3. My question is, do we have this rule? That means each time I have an attribute B, I will automatically have the attribute C. This is B, and this is C, which means here I do have B1. Whenever I do have B1, which represent, okay, B1, which represent the attribute B, can we say each time I do have B1, I do have C1? In my case here, I do have only one B1. I don't have any problem, okay? Now, if I go to B2, if you look here, Shabab, here I do have B2. This is B2, which represent this B. Can we say each time I do have B2 in this column, I will have the corresponding C2 in this column. For this B2, I do have C2. And I do have another B2. B2, I do have C2. That means it is correct. If you can see here, each time I give you the value of B, which is B2, automatically I can give you the value of C, which is C2. I don't have any problem. I don't have any violation. That means it is correct. B3, C4, I don't have any other B3, so that's fine. That means this one can be considered as a functional dependency. If I tell you, for instance, the inverse, CB, if I know C, I can give you automatically B. Just look at C, the column, C and B. Just look for those attributes that are repeated. For the one that are not repeated, it is okay. C1 gives you me B1, okay? C1, which represent this part, left-hand side. B1, which represent B. That means each time I do have C1, I have B1. C1, B1, okay? I have no objection, no violation. Do I have other C1? I don't have it. Let's have a look. C2 now. Here I do have C2. C2, the first C2, which correspond to this C, will give me B2, which is on the other side. What about the second C2? C2 gives me also B2. That means it is correct. Each time, this is the meaning of the functional dependency. Each time I do have something, attribute, one or many, in the left-hand side, I can automatically have the right-hand side. That means C2 on the left-hand side gives me B2. C2, another C2 gives me the same one. That means this is verified. There is no violation. C4, B3, it's okay. I don't have another C4. That means I can deal with it. Now, I will give you another tricky one. Let's have a look, for instance, for this functional dependency. If I tell you, for instance, A, B, and AP will give me C. Sorry, B, bigger B, uppercase. This functional dependency. What do you think about this functional dependency?
I think it's false.
Of A and B.
AB, which means if I pick up an attribute from A and an attribute from B, the combination will give me the exact value, and a value for A or value for B together will give me exact value for C.
Yeah, there is a violation.
If you can see here, A, B, we said that combination of A, B will give me C. Okay? Now, if we pick up the combination, if I am telling you about the combination, let's, for instance, the first example, let's say A1 with B1, which I am picking up, okay? In my functional dependency, in this table, what it gives me in C? What is the value of the attribute C? If I combine A1, B1, C1. Okay, good. C1. Okay. The second one, A1 B1 gives me C1. The combination هذا الاثنين. Okay, A1 B1. Okay, this A1 B1, because A1 is from A, B1 is from B. This is what the functional dependency. A, B gives me C. We see what is the value of C, which is in first line C1. A1 B2. I do have C2. A2 B2 gives me C2. A3 B3 gives me C4. I don't have a repetition here. I don't have a problem. The problem will arise if you do have some repetition in the combination or in the left hand side. You have to make sure that always you should get the same value. Who said there is a violation, Shabab? Who said there is a violation?
أنا لأنه عند C2 في two combinations A1 B2 and A2 B2.
نعم.
لأنه for C2 we have two combinations A1 B2 and A2 B2. That's why I said the violation.
For A4, AB, yes.
Yeah.
A1, B.
Yeah.
No, I will just look on the left side, hand side here. A1 B1 and A1 B2. It's different.
No violation. No violation.
Okay, it's different. صح لو كان عندنا هنا B1 كان هنا B1, yes, there is a violation because the same value on the left hand side doesn't give you the same value on the right hand side. But here they are different. A1 B1, A1 B2, there is no problem. Okay?
Doctor.
نعم.
It could be a problem if we have C in the left side and A and B in the right side, right?
نعم.
It could be a problem if we have C in left side and A and B in right side.
C1, yes, because of this one.
C2
here C
give me two different
gives you A1 B2 و C2 هنا تعطيكم A2 B2. Yes, you're right. Let's have a look at this one. A to B. Do you think it is a functional dependency? ولا لا? A to B.
No.
No, it's not.
No.
Why?
No.
There's a violation.
A1 gives me
A1
two
has
different
two values.
Enough A1 that correspond to A and the B1. And here A1 I do have B2, which is different. That means what this means if I want to write it. If I want to write here, I will say that A1 in the first example, for instance, A1 gives me B1, and in another line, A1 it is giving me B2. If you can see here, they are different. And within functional dependency, what we said functional dependency, we said each time I do have a value in the left side, I should have a value on the right side. Here it is different. Here what I do have, for instance, A1 gives me B1, but A1 here gives me B2, which is not correct. That means this cannot be considered as functional dependency. It does violate the definition of functional dependency. Okay, Shabab? Let's quickly DC. Okay, I do have D, and
Yes,
I do have
there
C.
is a problem.
What is the problem here?
D is repeated.
Both
D
give
is
the
repeated.
D2.
D1, C1, it is okay. Okay.
D2.
D2, C2, yes. I don't have another D2.
Okay.
هنا D3.
D3.
In one line, D3 gives me C2. هذا D3, which correspond to D, with C2 correspond to C. D3 gives me يعطيني C2. But in the other line, D3 gives me another value, C4, which is different from C2. That means this one cannot be considered as a functional dependency. Okay, guys? BA. What about BA? From
B2
B,
gives two values, so no.
BA. That means what we do have here. That means this one cannot be considered. Okay, BA. B1 يعطيني A1. Do we have another B1? No. That means I don't have any problem. B2 gives me A1. And another B2 gives me another value, another different value, A2. A1 is different from A2. That means like we did here. A1 أعطاني B1, A1 أعطاني B2. هنا B2 gives me A1 and B2 gives me A2, which is different. And the functional dependency, we say that each time I do have something on the left-hand side, the value, I will automatically have the value of A. I know the value of A. Okay, if I tell you, for instance, if it was a functional dependency, I would say, if I tell you the corresponding which value depend on B2. You will tell me A1. But here, another one, we said, no, I do have another line which says A2. That means this cannot be considered as functional dependency. Okay, Shabab? So this way, in this manner, you define the functional dependency, and all normalization is based on functional dependency. It is very important to understand functional dependency in order to utilize it, to use it in your normalization process. Okay? Now,
what if we say A to B? So we have two. What if we say A to B? We have two different.
خلاص we said أعطيناها شرحناها. A to B قلنا A1 يعطيني B1 و A1 يعطيني B2, which is different. B1 is different from B2. معناه A to B is not considered as a functional dependency.
Sorry about that. I mean, if we have, let's say, on the left-hand side, we have the same. We have different values.
We cannot say you have different values. We should have the same value to specify. Just give me what is your functional dependency. A to B, or A to C, or A to D, or A, B, C. What is your functional dependency in order to see whether it is correct or not.
Okay. So let's imagine that you have A1, A2, A3, and A4.
La, just tell me A, B, C, D. What is left-hand side? Don't tell me A1, B1, C1. What is on your left hand? Like I did here. A, B, B, C. What is on your left-hand side? What is the corresponding attribute?
Not sure if there is an example here.
No, just give me what you want to arrive. What is the question exactly? If you have, for instance, A, this is what you mean. If you do have A, C, do I have, for instance, D? هذا.
No. So we know that, for example, C to D is false because we have C2 giving two different outputs, right?
Okay. Yes.
But what if let's say we have C2 and C3, or let's say C1 and C2 giving the same output? Is this
doesn't
going to be false?
نعم. لا, doesn't matter. المهم, the same value on the left-hand side should give you the same value on the right side. Each time you know the value of the left-hand side, you should automatically tell me what is the right-hand side. This is the functional dependency. Okay. Doesn't matter if you do have two different attributes gives you the same on the right-hand side. Doesn't matter. The main thing is each time you pick up attribute واحد ولا many attribute on the left-hand side, automatically you should tell me exactly what is on the right side. If I tell you, for instance, here employee number, automatically you should tell me it gives you the email address. Employee number here, I do have email address. I do have functional first name. I do have a last name. That means this is the correct thing. Okay, it must exist. This is what is known as a functional dependency that is specifically based on a primary key, for instance. Okay. So now in terms of transitivity, what is meant by transitivity? Okay, we say that we do have transitive dependency. If I do have, for instance, attribute A, B, and C, I do have those functional dependency A to B. I do have B to C. And we say that functional dependency are transitive. That means we will have A to C. Okay, if you can see, it's like a transitivity in algebra. Okay, we say that C, this functional dependency, has been created by transitivity. We didn't create it as a functional dependency separately or independent, but because I do have from A to B and B to C, automatically I will say I do have functional dependency A to C. If I do have, this is transitivity, and we say that C is transitively dependent on A via B. Okay, because of that B to C and A to B. Because of that B that is repeating, that's why we said that I do have A to C. And this is another concept that is very important in normalization. You're going to see later. Okay, like we do have here. Okay, I do have, for instance, employee. Okay, what we do have here? We do have employee number. gives me employee email, and it gives me department number. And I do have here department number gives me department name. If you can see here, from A to B, from B to C, I will say I will have automatically A to C, which is employee number. Automatically, I do have department name. And I will say that department name, this department name, which was not at the beginning. Okay. Now, by transitivity, I do have it now. That means department name is transitively dependent on employee number because of the department name, because of this, that will go to this also. This is another example of transitivity in functional dependency. Another concept, which is also very important, if you understand this concept, خلاص, you are done with the normalization process. We do have what is known as a partial dependency. Partial dependency exists. We say that a partial dependency exists when an attribute B is functionally dependent on an attribute A, and A is a component of multi-part candidate key. If you remember when we said about candidate key, let's consider it here, for instance, inventory number and line number that are both underlined. Okay, that means they are multi-part candidate key. That means that you have here key that is made up of two candidate key. Now, inventory date is, we say that inventory date is partially dependent on this and this. Why? Because we don't need to know both of them, of those two attributes, inventory number and line number, to give you the inventory date. This is why we said that the inventory name, for instance, inventory name is, for instance, is we can look to determinant, because knowing only the inventory number, I can give you the inventory date. Knowing line number, for instance, I can give you, for instance, because it is part of the key. I don't need to have this combination in order to give you inventory date, like we did last time. Let me see here, for instance. If you remember what we did, for instance, if I tell you I do have, let's say, knowing, for instance, SSN and department, okay, department, for instance, number, okay, I can give you employee name. What do you think about this one? Is it necessary to have both SSN and department number to know the employee name?
I think
Because one is
SSN is enough.
Barakallahu fikum. SSN
but-
is enough. SSN is enough. And this is what we mean by partial. معناه we don't need, okay, all the attribute on the left hand side to determine the right hand side. That means this e-name is partially dependent on what? On only SSN. That's why I shouldn't have this one. Okay, because I don't need it on the left hand side. I only need SSN. Knowing SSN, automatically I give you e-name. Okay, Shabab?
we can do the same, doctor, always with when we have a primary key, right?
Yes, yes.
But we
Yes,
can
this
do.
is-
We can also do it with non-primary keys or not.
We're
But,
going to see later. Normally, we cannot do it. We
Okay.
never, you should never put on the left-hand side something that is not primary key.
Okay, okay.
Okay? It can be combination primary key, but no, it's not acceptable to have something that is not a primary key on the left-hand side. So in this case, what we do have a partial dependency, juz'iyya. This is what you mean by partial. That means it is not necessarily to have all the attribute on the left-hand side to give you, for instance, to know the value of the right-hand side. Okay? So now, in terms of normalization, which is based on primary key. We said that we do the conceptual schema design, which is based on after we do the mapping on the AR. Okay, then we define, for instance, in the functional dependency, we'll have a relation schema. As you remember, we can do it from an AR diagram. We do the mapping, or you do your design based on something that will be extracted from file, from formula report. Like here, for instance, this is a report. Okay, and based on the meaning, based on the semantic of this report, I can define the relation schema. I can guess that I do have a physician ID, patient name, patient number, location, physician. This is the name of the physician, for instance, his phone number. So based on this information that will be extracted from this report, okay, I can tell you, I can automatically gives you, for instance, the relational schema. I can give you the design and tell you what are the probable relations and what are their attributes only based on this type of report. This is one way. Another way is to have an ER diagram. Based on the ER diagram, you do your mapping like we did last time, and you get your relation schema. Okay, so whether you follow the first approach or the second approach, okay, it is very important to verify whether those relation schema that you have designed are good or not. Okay, now this is what we mean by normalization. Once you do have your relation design, your relation schema, you need to tell us whether those relations have some level of goodness, okay, or they need more to be more refined. Okay, and when you talk about normalization of a relation, معناه you take the relation schema through a series of tests. We do some tests and verify whether my relation schema is for instance have or satisfies some normal form. We call them normal form. Okay, this is what is meant by normalization. Normalization معناه you will have, for instance, some relation. Okay, you will have some relation. Let's say this is, for instance, a relation that I have defined. Okay, then let's say consider you do have 3 levels of goodness. Okay, this is the top level. Okay, and I will tell you later that this is called NF, first normal. Then I will have what is known as 2NF, second normal. And I will have the highest level, will have the 3NF. This is 3NF or third normal form. Now what you will do, you will have your schema, relation schema, and verify whether your schema, okay, is at 1NF. I will ask myself if it is okay. If it is in 1NF, معناه at least you have some goodness, you have some level of goodness, but you are not satisfied. I want to bring my relation into higher level. Okay, then I will ask myself whether my relation schema is into an F formula. If it is okay, that means my relation schema has, it's like grading. Okay, here you have 1, 2, 3. Then if you have 1, you give 1. That means there are some criteria. You verify whether there are on your relation schema. If they are verified, I will say my schema is 1NF. Then I will move to second NF. Verify. I will verify is my relation schema has grade 2 or not. I will verify there are some criteria. If there are there, I will say yes, my relation is 2NF. Another guy will say I'm not happy. I want to make my relation very good schema. That means I want to verify whether it satisfies all the conditions in 3NF. We're going to see later what are those conditions. If this condition is verified, I will tell my schema is 3NF. معناها وصلت to the top level of goodness. معناها my relation schema is good. I will not have any problem later when I go to the implementation. So these are what is known as normalization, process of normalization. You have the set of criteria for each level and verify. If they are there, I will say my relation in 1NF ولا 2NF ولا 3NF. نعم.
Who will decide these criteria, Doctor?
نعم.
Who will decide the criteria for each level?
They are predefined. This is like an algorithm that has been created and defined by some scientists, and they said that this is the way. They found a way that to verify that the goodness. It's like something that quantitative. You verify whether your schema will satisfy, and by experience, they define that these are the good. There are, for instance, there one of the scientists known as Boyce. Okay, he defined another criteria to verify whether relation is good, has a good some level of goodness or not. Okay,
Doctor.
Now,
sorry, just again, what does 1NF stand for?
I will tell you. Well, normal form. Normal form. We're talking about normalization. Normal form. Okay, the normal form of a relation refers, as I mentioned, to the highest normal form condition. I will verify if that condition is verified, it is met. That means it indicates the degree to which your relation has been normalized. Okay, I will tell you, for instance, if I only verified 1NF, I didn't go through 2NF or 3NF, I will say my relation satisfies 1NF. Another person will take that relation and verify whether it satisfies 1 and 2NF. Will say, if yes, I will say my relation is second normal form of goodness. Ula grade 2, if you want to call it. It has grade 2. Ula mark, it does have 2 points. That means 2 points better than 1 point for the relation. And another guy will say, no, I want to have more points. I will verify and I will translate and make my relation satisfies 3NF condition. Because when you create a relation schema at the beginning, it is not necessary. It is not necessarily 3NF. You have to verify it. Sometimes automatically it is 1NF. Okay. Sometimes it is 1NF and 2NF. But it is not in 3NF, and you have to make it 3NF, for instance. So I have to decompose it, to divide it into small. And what are the problems normally that arises if it is not 3NF or 2NF? Because you do have a bigger relation schema. When you do have bigger relation schema and you do have a lot of attributes, mixed attributes, you will have such problem. You're going to see later, inshallah. Okay, so the normalization of data. Okay, when you do normalization schema based on the functional dependency and the primary key. So what we need to do, what is the objective, is to minimize redundancy. When you make your relation schema 1, 2, 3, and F, you are trying to minimize redundancy. This is the first thing. And if you remember what we said about the anomalies when we do insertion, deletion, and update that we have discussed last time, you will try to minimize them, because if you don't do that types of normalization, you will have a lot of problem appearing later. So what you need to do, you need to try to minimize those problems that might happen later when you try to populate, to put your data inside your database. And what we said about, what we are saying about unsatisfactory relation schema, your schema, your design, your relation design does not meet some condition that are related to the normal form test. Maybe my relation schema meets condition of 1NF, but it doesn't meet the condition of 2NF. It is not 2NF. I cannot give it 2 points. Why? Because the condition that needs to be verified are not met. And this is what we mean by it is unsatisfactory relation schema. I can give my relation 2 points, but I cannot give it 3 points. Why? Because based on some condition of 3 and F, those conditions are not verified. If I want to make it 3 and F, I have to make those conditions, my relation schema meets those conditions in order to tell my normalization, my relation schema is 3 and F. Okay. Now let's have a look at some types of property for the relation schema. Okay. we're going to leave for the join property. I will leave it later when we talk about SQL to understand what is meant by join. And we talk about, let's have a look at, we have already defined the super key. I'm not going to repeat it. Yes, this is another definition that is very important. Okay, we say an attribute of a relation is called a prime attribute of R if it is a member of some candidate key of R. If you remember, we have already defined candidate key. We said that candidate key are those attributes that can be considered as a primary key. Number plate for the car, for instance, car number plate or car chassis number, both of them can be considered as candidate key. They can be chosen as a primary key. Okay? And when we say an attribute is non-prime, okay, if it is not a prime attribute, it is not a member of a candidate key. Now this is a very important concept. Okay, if an attribute is a member of a candidate key, I will say, for instance, it is a prime attribute. Okay, like we did last time. For instance, I tell you, for instance, the candidate key for the car relation, I can have, for instance, number plate, and I can have, for instance, also chassis number. Chassis number. Okay, these two attributes can be considered as, okay, primary key. Okay, this is why we call them candidate key. Number plate on its own can be considered as a primary key, and the chassis number can be considered as a primary key as well. Okay, Shabab? So this is what we mean by this is a candidate key and this is a candidate key. And this candidate key is called a prime number. Okay, as we called it here, a prime attribute. This is a prime attribute and this is a prime attribute. Because why? Because they are part of candidate key. This is candidate key list. Okay, in my, for instance, if we pick up an example of a car relation, I will say candidate key list. Okay, that means all the attributes that can be considered as a primary key. Chassis number with S. Chassis number is primary. It can be considered as a primary key. Okay, and number plate can be considered as a primary key. Now, if I tell you, for instance, if I am going to add something extra, what about car model? And the car model be considered as a candidate key, ولا لا شباب?
No.
Why?
Because there are a lot of cars of the same model.
Yes, we can have. If I tell you car model is primary key, there is nothing. You cannot tell me what is the number plate, or you cannot tell me what is the color, because there are many car models. That means it is not unique. So I cannot make it an element of candidate key. It cannot be considered as a primary key. So I will remove it. It is a non-prime key. It is non-prime attribute. That means which is any attribute that is not in the list of the candidate key, it is considered as a non-prime attribute. Okay. Now, quickly, 1NF, it is very simple for 1NF to verify whether your relation is, for instance, is 1NF. Okay, it is by definition. It is based on the atomic. If you remember, atomic معناها indivisible value. Okay, that means when you define your relation, all the attributes should be atomic value. We cannot have composite value. We cannot have a composite value in the relation. If you see that when you define your relation, you do have composite value, you should divide them. Here we said we remove the attribute that is not atomic and we place it in a separate relation. We create another relation where we put that value of that attribute and we expand the key. Expand the key معناه we take the parent, the primary key of the parent, and we add it also to the new relation. and we use several atomic attributes. Let's have a look at an example. Okay, if you see, for instance, this FD, I do have relation D name, D number, department manager, and department location. And if I go to the department, the values, if you see that the department location is a composite. I do have a Bel Air location, Sagarland location, and Houston location. If I tell you, for instance, I do have D number, D name, D number, department manager, can you tell me which location, the department location, Shabab?
No.
Why?
There are 3. Which one?
Barakallah fiik. We cannot say this research, department name research with department number 5 with the department manager SSN this value, it corresponds exactly to the location below ولا هذا ولا هذا. So that means here we do have a problem. Okay, we do have a problem because of the location is not atomic. It doesn't have only one value. It can accept more than value, like we did last time. Certification for an employee. An employee can have many certification. So I cannot tell you if I give you the SSN of that employee, and I will tell you this employee has exactly this certification because he has many certifications. So what is the solution? Okay, is to take that, let's say, department. Okay, we divide it. We just divide that delocation, okay, into unique one with repeating. Okay, this is what we said. We propagate the primary key into it. We remove nested relation attribute. This is considered as nested, that because we do have many values. We remove that one. Okay, we make it, we unnest relation into 1 and F. That means we make that attribute atomic because now it is not atomic. It accepts more than one value. I will make it atomic, and for each value of it, I will what? I will propagate the primary key. That means I will move that D number. Look at here. From this relation, we went to this relation. Now, what I have in the first line, research 5 with this one, I do have location Bel Air. I do have atomic value. I don't have many values. Research 5, I don't, even if you do have repetition, don't look at, we do have redundancy. There is no problem with redundancy. Here, what we are verifying, Shabab, what we are verifying whether your relation is 1 and F. This is what we are verifying. Even if we do have repetition, if we do have redundancy, we don't care about it at this moment. Okay, what we care is, do we have all the attributes accept only one value ولا لا? If yes, all the attributes are, we say all attributes are atomic, yes, معناه my relation is 1 and F. It is straightforward. It is very simple for the 1 and F. Just make sure that all the attributes you do have are atomic. معناه on the specifically when you talk about the right hand side, when you do have functional dependency, knowing the D number, I can give you department manager, the location, and D name. Because here we do have a problem of many locations, so we will divide, we will move that delocation and divide it into those different values. Okay, Bel Air in one line, this is Sagaland in another line, Houston in another line, and so on. And
but
we say
now we have two primary key, right? A primary key. We have one composite primary key.
لا we always have the same primary key. We said that propagate. وش معنى propagate؟ معناه those new lines that have been added. هنا شحال كان عندي؟ كم عندي من line؟ 1 2 3. Now we do have 1 2 3 4 5. What I have added? I have added this and this and this, and they will have. I will use the same primary key that was in the parent relation. This is what means by propagate. That means this line will have the same primary key, D number, D number. Research, this line will have the same primary key. I don't have any extra primary key.
Because they write line under D location.
نعم.
There is line under D location.
Oh yes, 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 of course, yes. Okay, barakallah. Yes, yes. To differentiate, yes, to differentiate, because I was talking about atomic. to differentiate between this line, or this tuple, and this tuple, of course, I need to have combination of the number and the location. Because if this delocation was not primary key, if I tell you I do have the name research, the number 5, manager 5555, you cannot tell me exactly which location, because these 3 values, the name, the number, the department manager, are the same. So here we propagate, we combine, we add to our location, to our relation, the primary key, that the location. So now the combination of the number and the location, okay, automatically I can give you, for instance, you can differentiate between this tuple and this tuple. Why? Because at least we do have, even we do have the number the same, at least we do have the location is not the same. That means the combination will never be the same for any other tuple. Because like here, for instance, I do have Houston, I do have Houston here. The location is the same, but the D number is different, 5, and they do have here 1. معناه this tuple is different from this tuple, even if they share some attribute. For instance, for these 3, they share the same 3 attribute. We do have redundancy, but we do have different delocation, which is part of my key. Okay, Shabab? So that means when we talk about, it's like here, this is what we mean by nested. This is another example, employee project. Because number of hours, I do have project number, I do have many number of project number, and for each project number, I do have different number of hours that an employee has worked. Okay, so you need, for instance, to divide it into, like here, for instance, we have divided into SSN E name on its own and SSN P number on its own with the number of hours. In this manner, you will have automatically, okay, different lines, okay, different tuples with a combination of P number SSN, because that P number, okay, is does have multi-valued. So we propagate. SSN was a primary key. Now in my new relation schema, SSN and P number will be considered as my primary key in the employee project 2, for instance. Okay, so here what we did, we picked up this big relation SSN E name P number hours, and we divided into 2 relations, SSN E name, and I do have SSN P number combined with the number together will give me the hours. Because if I know the SSN and the project number, I can tell you how many hours that person has worked on that project. This number with 1, I can tell you 32.5. This number with 2, I can tell you he works 7.5 in project number 2, and so on. If you can see here, we do have many values for the project number. But if I combine SSN with project number 2, I can tell you exactly how many hours this guy has worked on project 2, or project 3, or whatever the project 30, anything. Okay, so this is which is known as the first normal. And as I mentioned just previously, this one, if I tell you, for instance, whether it is 1NF or la, it is not. Why it is not 1NF?
Because we have no atomic.
Not atomic. Employee degree is not atomic. Here we do have 3 values. It is not a single value. And here I do have the 2 values. This guy has BSc as a degree, and he has an MSc as a degree. It is multi-valued. Okay, but we need to divide it now.
Is empty value affect 1NF?
La. Only if you do have multi-valued.
Multi-value, okay.
Okay, if you can see here, we have moved it. Here we moved employee number, employee phone, and we divided that employee degree, employee number, and we divide it. Okay, now it is atomic. It does accept, this column accepts only 1 value. It's not like in the previous one. Here it did accept 3 values or more. But here in my new, okay, I just divide employee number, employee phone number, and employee number, employee degree. Now both of them will be considered as a primary key in my new relation, which is called employee degree. This is what is known as a first normal. Okay, Shabab? So we stop here. We go tomorrow, inshallah. We're going to see